definitions about what is defined, what is limit, and what is continuity. Talk about at a single point, whether it's defined or limit exists or continuous at that point. And then we talk about how to evaluate limit, like we have lim for a constant, it's always the constant itself. When you can substitute the value in, you directly substitute that. When you can't substitute, you need to simplify it first and make the denominator not zero and then able to substitute. And then we have talked about the graph, why there's an open circle on the graph, because the implied domain. And then we talk about the three definitions for continuity, what is continuous, how you can state or discuss whether it's continuous or not by using those three rules. And the rule number 2 is talk about limit. There's another 4 line you need to write for limit exist or not exist. And then number 3, we talk about only hybrid function was me to think about whether it's continuous or not. If it's just a function, it's always continuous. But because we have the connection point, then we need to test about the connecting point, whether it's connect together or it's a jump there. So that's the continuity. And today we're going to talk about the derivative. So we go back to the calculation topic, but this is still some definition here. So what is derivative? Well, before we do derivative, we need to learn one definition, which is the average rate of change. So what is average rate of change? That is between 2 points, what is the gradient of the 2 points? So that is called the average rate of change. So it basically is y2 minus y1 over x2 minus x1. That's the gradient function. So if you have a point here and you have a point here, well, it can be a curve, follow like a curve like this. Well, it can be a curve. It's not like increase in a linear. But when we talk about the average rate of change, that's the same as we connect those 2 points. And then we think about the horizontal movement, and we think about the vertical movement. It's not really vertical. That's the vertical, and that's the horizontal movement. So you think about for each x move, how much y has increased. So that's the average rate of change. So one more thing is talk about the instantaneous rate of change. So instantaneous rate of change is talk about the gradient of the tangent. That equivalent to talk about the gradient of the tangent. So at that instant, what is the rate of change? How fast is increasing or how fast is decreasing? And that is equivalent to the derivative. And derivative is f dash x. So they are the same thing. Okay, instantaneous rate of change equals to the gradient of the tangent, and that is the derivative, and that's the f dash x. So we are talking about the same thing for those 4. How to find the gradient of the tangent? We can evaluate by a numerical approach. I'm not sure if you still remember that. So last year we learned if there's a curve, I want to find the instantaneous rate of change. So I want to talk about the instantaneous rate of change. For example, I'm talking about this point here. This point here. So the gradient, well, the tangent looks like this. Okay, that's the tangent. And then I can find the gradient of, I want to find the gradient of tangent. But it's like how? Before we know how to do derivative, how we can find it. So the way we use is a numerical approach is we select a point which is really, really, really close to this point. Okay, for example here. I'm not sure if you can see it. Yep, you can see it. There's another point there. I'll select a point really close to it. How close? Maybe x increases only 0.0001, like a really small value. It's still 2 separate points. It's still 2 points on the graph, but it's just really close to each other. So because they are really close to each other, why draw it? Can you see it's quite, when I connect those 2 points together, can you see it's actually quite close to that red line? Is, well, think about that. That's 0.1 apart maybe. If you get even closer, that's almost the same line. Okay, the green one and the red one will become almost the same line. It's very, very, very close to each other. So we can actually use the average rate of change formula to evaluate the gradient at the at that instant. But it's an approximation. It's an approximation, but it's a really close approximation because it's almost the same line. It's almost the same line. So the formula we use is this average rate of change formula. That's the y2 minus y1. Okay, y at the bottom is just h. What I will have is a plus h minus a, because a plus h is the increase, the x value of the new point, and then minus a, which is the current point, which is x1. So it's x2 minus x1. Yeah, so it's x2 minus x1. I have used the average rate of change formula to evaluate the instantaneous rate of change by make h become an extremely small number. Okay, make h as an extremely small number, 0.00000001. As small as, well, the smaller the better. The smaller, the closer to the actual gradient. And now let's think about the limit. Okay, that's why I go through limit first. I think the book is like not really put this in a right order. They talk about limit here and then explain what is limit in the exercise L. Okay, after we have done exercise A, like what's the point to discuss about that? So because we have learned that already, we know what is limit. Limit is when h getting approach to that value. What is the y value approaching to, right? I'm not really get onto 0. I'm not make h equals to 0, but I'm get as closer as possible to 0. Okay? So the formula we create is this one. Okay, this is the y2 minus y1 over x2 minus x1 formula. But we put a limit for this function. The limit I make h approaching to 0. Then this will give me exact the gradient at x equals to a. Okay, the exact gradient at x equals to a. Because what is approaching to? Well, you can never really get h equals to 0. But you know that will be an open circle there? That will be an open circle. So when the 2 point get close to that 0, so the y value you get will be the exact gradient of the instantaneous rate of change at x equals to a. Okay, then we say f dash a means the instantaneous gradient at x equals to a. And we make it in more general form. A is a particular point. For example, A is 2, A is 3. We can make it more general by substitute x into this formula. You substitute x into this formula. Then we have this equation here. What's that equation? Well, we just change all the a to x. Nothing wrong with it. Well, a is a variable, x is a variable as well. But this one can allow us to find the general rule for the gradient function at any point. I can sub 1, 2, 3, 4 later. We have a gradient function. So f dash x is the limit h approaching to 0 by put the average rate of change equation there. So it's exactly the same as a single point A, but this is making more general by sub x into the function. And then this is the first principle. This is the first principle. So every time you see first principle, just copy this line. Or remember this line, that's your starting point. Okay, just write down this one. Okay, first principle, okay, f dash x equals to lim h approaching to 0, fx plus h minus fx over h. Okay, that's the first thing you write. And then according to what is the fx, you substitute, you change the rule for the second line. But first principle is always that. So the specific point is this one. For example, you want to find the gradient at x equals to 2. What you can find is f dash 2 equals to lim h approaching to 0, f2 plus h minus f2 over h. So that's find one point. But this one will give you an equation, a formula, okay, give you a formula. So for example, f dash x equals to 2x plus 1. Now you can substitute x equals to 1, 2, or 3. Okay, before we go through first principle, let's have a think. What are these? What's lim h approaching to 0 of 3? Evaluate. 3, good, 3. Okay, what's lim h approaching to 0 of 3x? you sub h equals to 0. And where's h? There's no h. So just got 3x. There's no h. Well, yeah, I still sub h equals to 0, but there's no h. So whatever left, well, I can still substitute. It's not like I can't substitute. I can't evaluate when the denominator is 0. But this case is just, I don't have h to substitute. Doesn't mean I can't substitute. I still can. So what I'll get is, by substitute h equals to 0, which means I haven't substituted anything, and I just have 3x here. Okay, so, well, what's the next one will be then? What's the next one will be? 2x squared minus 3x, that's right. Yeah, 2x squared minus 3x. H becomes 0, 0. What we left is 2. That's quite similar to a constant. There's no influence. Whatever h take is no influence on the x value. So just keep the same. Okay, next one. I can't substitute h equals to 0 because denominator is 0 here. So what I will do is keep lim approaching h, 3x squared plus 4. Okay, divide h, divide by h. Now I want to sub h, but there's nowhere to sub h. I can just go for 3x squared plus 4. That's the answer. Any questions? Okay, no questions. Then we will investigate a question which can help you understand this better. For the curve with equation x squared minus 2x, okay, a quadratic x squared minus 2x, we can sketch it. That graph is given there. And find the gradient of the chord PQ, where P is a point at x equals to 3. Let's label where's P. That's 3 and F3, right? I'm not evaluating that yet. I'll just put F3 instead of the Y value. That's the P. I have a point Q. Q is 3 plus H. 3 plus H. Well, I can put Q anywhere. How about here? So if I put Q here, the X value is 3 plus H. The Y value is F3 plus H. All right. And we want to find the gradient. We want to find the gradient between those 2 points. Gradient of the chord. So what is chord? Chord is the line connecting by those two. Well, connecting those 2 points. Well, it quite looks like a straight line, but it's actually not. Well, it's a straight line here. Okay, so I also find the gradient of that chord. Well, I can say it's a linear if I extend it. So what I want to do is the gradient will just equals to f bracket 3 plus h minus f3 over h. y2 minus y1 over x2 minus x1. So f3 plus h, you know fx is that. f3 plus h will be 3 plus h squared minus 2 3 plus h minus f3. f3 is 3 squared minus 2 times 3 over h. So this equals to 9 plus 6h. Well, expand it, plus h squared minus 6 minus 2h. And what's the bracket? 9 minus 6, which is a minus 3. And then over h. 9, 6, and 3 cancel. So what we have here is h squared plus 4h over h. And that's h plus 4, or 4 plus h. Well, I'll write in 4 plus h. Well, the gradient will depend on what is h. Well, the larger the h, the larger the gradient, right? Like for example, if h is 1, so the point is 3f3, 4f4, so the gradient will be just 5. You add 1 onto that. So find the gradient of the curve at PQ when h equals to 1. So when h equals to 1, the gradient equals to 4.1, 0.1, so not 1. So the gradient is just 4.1. Just sub h as 0.1. Okay, C. Find the gradient of the curve at the point P. There's only a single point given. That's the instantaneous rate of change. Instantaneous rate of change. That's the instantaneous rate of change. So at a point, a single point, instantaneous rate of change will be represented by f-3. That's what I'm looking for, the instantaneous rate of change. That's f-3. And f-3 will equals to limit h approaching to 0, f3 plus h minus f3 over h, right? That's the formula we talked about at the very beginning. That's the formula. Also, from part exercise A, like part A, we have this as 4 plus h. Remember, we have simplified that notation already. That's 4 plus h in A. Okay, exercise A here. So that is just 4. By sub h equals to 0, what we have is 4. So the instantaneous rate of change at 3 is 4. Okay, the instantaneous rate of change at 3 is 4. Alright, next one. Use the first principle. Find the gradient of fx at any point of x. Okay, when you see the word first principles, you write f dash x equals to lim h approaching to 0, x plus h, not 3, minus fx over h. Well, every question will be the same, because first principle is this. And then we think, what is fx? Okay, what is fx? We're trying to apply the rule into this. So this equals to lim h approaching to 0 and x plus h. Okay, what's the rule? Forgot. X squared minus 2x. So fx equals to x squared minus 2x. So fx plus h will be x plus h squared minus 2 bracket x plus h minus fx. Well, remember to put fx in the bracket over h, just by expanding it. And now I will expand. Because I can't substitute. If I can substitute, I can directly substitute h equals to 0. But because I can't substitute, denominator is 0 now. What I need to do is expansion. So we have x squared plus 2h times x plus h squared minus 2x minus 2h minus x squared plus 2x. And then this over h. Just expansion. So x squared disappeared. 2x 2x disappeared, what I will have is lim h approaching to 0. Okay, 2hx divided by h, we have 2x. H squared divided by h, we have h. Minus 2h divided by h, we have 2. So that's the simplified version. And I can sub h equals to 0. We have 2x minus 2. So what I have here is f dash x equals to 2x minus 2. Okay, hence find the gradient of the tangent at x equals to 3. Remember, we have done this already by another method. We use kind of first principle, but for a single point to work it out already. We can check the result. So f dash 3 will be the gradient at x equals to 3. That equals to 2 times 3 minus 2. That gives me 4, which is the same result as the two questions above it. So which means we get it right. And then the gradient at x equals to a, so f dash a equals to 2a minus 2. Last one said, find the coordinates of the point on the curve at which the gradient of the tangent equals to 0. Which point do you think the gradient of the tangent will be 0? What kind of line got the gradient of 0? What kind of linear? Horizontal line. Vertical is undefined. Horizontal is gradient of 0. Okay, there's only got x change, but there's no vertical change. So 0 over anything will still be 0. So the gradient of a horizontal line will be 0. Can you see which tangent must be a horizontal tangent? Well, when you're trying to draw tangent, for example here, the tangent will look like this. Which point's tangent will be horizontal? Turning point. Turning point tangent will be horizontal. Can you see that? Other point will got a little bit gradient, here. So horizontal. Well, this is not like by solving. So this is just by thinking which point you think you should solve out. This point is, well, x-intercept is 0 and 2. So the x value of the turning point is just 1. Okay, in the middle. And I'll sub 1 into the function. I have 1 minus 2, which I have minus 1. So the point I solve out should be this point, because the gradient of the tangent at that point, I'll just sketch it. That should be the tangent. That should be the tangent. So what I can do is asking you which points gradient of the tangent will give you tangent equals to 0. So which basically I want to solve gradient equals to 0 is f dash x equals to 0. So f dash x equals to 0, which is 2x minus 2 equals to 0. And I can solve out x equals to 1. I want to find the coordinates. I'm not going to substitute back into the f dash x, but I'm going to sub into the fx to find the y value at x equals to 1. So that's 1 squared minus 2 times 1 equals to negative 1. Yep. So the tangent equals to 0 at the point 1, negative 1. That is your answer. Also, you can check. You know that's the turning point, and which means you get the right answer. Okay, you get the right answer. at example 3. Before you do example 3, I have a question. What is a plus, well, not plus, a minus b cubed? What's the expansion form for that? A squared, a cubed. And plus or minus? Minus 3 a squared b. Yeah, plus 3ab squared minus b cubed. If it's plus, then you change all the sign into plus. Okay, another one. A cubed minus b cubed. How to factorize that? It's cheating. A minus b. A squared plus ab plus b squared. Okay, what's a cubed minus plus b cubed? A plus b, a squared minus ab plus b squared. Okay, you need to remember the formula. Okay, so by giving you this rule here, I want you to try first principle by yourself to, well, do you still remember how to differentiate polynomials? What's the differentiation should be in this question? Okay, we get there finally. So minus 3x squared should be the answer. But like use first principle to show why it is the answer. Just let you know all the rule for the differentiation is actually coming from the first principle. So you use first principle to find the rule, and that's why we have all of this formula we can use here. So try to use first principle. Give you 5 minutes. I think that's enough. 5 minutes to do that. So when you see first principle, you will write lim h approaching to 0, fx plus h minus fx over h, and that equals to f dash x. Okay, that equals to f dash x. The whole thing there is equivalent to the f dash x. So I think we have a little bit problem with function notation. So what is fx? Fx equals to 3 minus x cubed. Then what is fx plus h? This is by changing all the x into x plus h. So that's 3 minus x plus h. Okay, change this x into x plus h. And then we cube that as well. So the whole thing gets cubed. Now we replace fx plus h by the notation here. And we replace fx by 3 minus fx cubed here. So what we have is lim h approaching to 0, 3 minus x plus h cubed minus fx, which is bracket 3 minus x cubed over h. And that equals to f dash x. And then lim h approaching to 0, we have 3 minus, okay, when you expand this, that needs to be in the bracket, x cubed plus 3a squared b plus 3ab squared plus b cubed. That's the expansion form. Minus 3 plus x cubed over h equals to f dash x. Lim h approaching to 0, 3 minus x cubed minus 3x squared h minus 3xh squared minus h cubed minus 3 plus x cubed over h equals to f dash x. Okay, just let you know, any term without a h needs to be cancelled. Well, if you can't, which means you do some calculation wrong. So, well, definitely 3 and 3, they can be cancelled. minus x cubed and positive x cubed, they get cancelled. Well, the rest of it all contain h, so I can just evaluate them. So lim, well, write it back. F dash x equals to lim h approaching to 0. So now what we have is minus 3x squared minus 3xh minus h squared. That's the simplified form. So f dash x equals to, now I can substitute h equals to 0 because h is not the denominator anymore. We are left with minus 3x squared. That's how we get the derivative. Okay, that's everything we have done. Basically, just change it to the proper rule. Do the substitution, simplification, and then sub h equals to 0. And you have the derivative. Well, you will, I don't think you will be asked about first principle, like, well, if they're really boring, they can put it in exam 1, like ask you to show first principle. Well, I think it did happen before, once or twice, maybe. But it's not like recently, it's not going to ask you like that boring things. It's very boring, like for me, like, yes, it's a very great rule. It's a very great rule because that's how we investigate all the differentiation rules, how we get those formulas. But it's not really helpful ask you to show all this algebra again. But you need to understand it. You need to understand it. The rest of the time, well, do you have 5 minutes left? Well, I want you to do this as homework. If you, well, it's not going to be a lot. Revise on differentiation just for polynomials. Like, is x to the power of n, the derivative is n times x to the power of n minus 1. That's it. That's just one rule. So trying to derive, well, n can be anything. Okay, n can be anything. N can be decimals, n can be fractions, n can be integers, negative values, n can be anything. But we all use the same rule. Okay, we all use the same rule. Be careful. X to the power of 2 can be differentiated as 2x to the power of 1. But 2 to the power of x, you can't derive it by that way. That's not a polynomial. That's not x to the power of n. That's n to the power of x. That's different. That's exponential. So this rule, we'll learn that later. What we only can do is when you have a number power, like a numerical power, then we can derive by this method. So the question I want you to do is example 1 here. Complete those ones. And well, 1, 2, 3, 4, 5, 6. Example 2. Don't do example 3. I'll go through example 3 with you together. First principle. I don't want to do first principle. Example 3 here. Example 3 and 9, F, A, and B. A and B. That's it. Example 1, A and B, and example 3, 2 questions here. Example 2 on this page, and example 1 this page. Alright? Derive those questions. I believe you can finish it. I trust you, okay? Before next lesson.
After the, what's the derivative? 3. -3.